So again, we're going to go over chapter 10.2 and 10.3. How I'm going to do this is, since they are stuck together, I should have separated it. But in this case, we're going to do the lecture, and then we're going to go ahead and do the exercise, take a break, and finish up the last part of the lecture, and then we'll see how far we get. But in this case, we're going to be learning chapter 10.2, time value of money. So, of course, with the assumption that we have inflation or we have a recession or any economic bloomings, our dollar will stretch upon its value. Okay, so of course, as we all know, $10 10 years ago is a lot more valued at than it is today, because today we have so much money pushing through into the system that it causes that our dollar has lost its value. And of course, our dollar is going to be based on the gold standard. With the new other type of form of currency out there, I think what we're planning to do now is going to take our dollar bill and compare it to a cryptocurrency. We'll see how that works out. But other than that, of course, understanding the concept that the value of $1 over time is not going to be the same as it is in the future. Now, what we can do is we can safely assume, right? I can safely assume that the dollar today shouldn't drastically change within the next year, right? Because if it does change, it changes by like 1/10 of a penny or even by a couple cents. But at least with that kind of mentality, I can make somewhat of a prediction in the future because my dollar value wouldn't change that drastically. But of course, if I'm looking at a projection where I'm talking about $1 today versus $1 in 20 years, that is where it's kind of going to be. Obviously, it's going to be a lot more than what it is. And that's what we're going to be doing today. We're going to be learning how time value of money works, and we're going to be looking at 2 different types of interest. So for today's lesson, we are not looking in the dollar in a sense of how much is it going to be or my profit's going to be. We're going to be looking in investing in either a bond or a credit card or a loan. Okay, so we're going to be learning that kind of interest. So there's 2 different types of things that we want to look at. We have a simple interest, and then we have a compound interest. All of us are very 100% familiar with the compound interest, right? That is typically any credit card today, any bank loan today, student loan, whatever you can list out. That is typically what the compound interest uses. Now, for a simple loan, one example that you would ever see in real life would be a bank bond or a savings. Okay, so I'm going to break down one at a time. So we're going to start off with our simple interest. So with our simple interest, we're looking at a lump sum value, right? We're looking at a large number, and we're only going to charge the interest once, or calculate the interest only one time. Okay, and with that, we have a few variables. We have the principal, which is your original investment. You have your interest rate, so this is always going to be measured in years. Okay, but if they give you a scenario where it's only 6 months, then you have to convert it into years. Okay, so we're looking at the percentage rate. I'm sorry. So when we're looking at a percentage, the interest rate, it's going to be given in an annual percentage. meaning that this interest is going to be charged once a year, and this is how much percentage of your original percentage that is going to be charged. And then time is usually given in years. Okay, our time needs to be converted into years. If you do have 6 months, you need to convert that time to equivalent for the actual, to measure the correct amount of time. So we'll take a couple examples on what to do with that, but usually those are the only 3 that you need. All right, only 3 that you need. Now I'm going to take a quick second and compare the difference between the simple interest and the compound interest. Now, the compound interest, right, depending on what kind of, interest you are looking at, whether it's a credit card, whether it's a loan, a student loan, whatever it is, typically those kind of compound interest, they hit you every single month. And usually those are the ones that are a little more dangerous, because if you ever heard of the 22 rule, you accumulate for every $100 that you owe, you accumulate that in 2 years with interest. All right, it's crazy. So for every $100 you owe, you accumulate $2,000 worth of interest within those years. So in this case, we're dealing with the length of time, but we're also dealing at how many times you're going to be charged this interest. Okay, and again, oftentimes you'll often see a monthly interest charge every month. And this one, where it's going to use the same exact variables, except we are thrown in one more variable, and that is it's n, and that is going to be the number of times compounded. So how many times are you going to be hit with the interest? So again, we have the principal, which is our original investment. We have our interest rate, which is always going to be an annual percentage, and we have time, which is usually given in years, but if it's not, convert it. So those are the 2 interests that we're going to be looking at. So again, now we're going to focus back on simple interest. Now, what can I do with simple interest? Well, you can solve for 2 things. You can solve for how much interest you will collect. And lastly, you will also determine how much the future value of that, how much future value would your original investment be within however X amount of time it's for. So here we're going to be looking at formulas. So here, everybody, this is a simple one, right? Because it's simple interest. I guess a mnemonic device to memorize this is pretty, right? PRT equals I, right? Pretty. Now, what that's going to do is it's pretty straightforward. You're going to multiply your principal, which is your original investment, multiply that by the rate times time, and you get your interest. Pretty straightforward. And then the formula to find your future value is you're just going to take your original investment and you're going to add the interest. And boom. That is how you'll know. Again. And then here is the formula, and below is the actual equation, right? PRT equals I, and then FV equals P plus I. So this is the one that everybody can do, because everyone has a calculator, right? This is the one that everyone can do. But I'm going to go ahead and go over the example, and when we move into compound, you're going to see how much complex it is compared to the simple interest, right? So here's an example on how to do a simple interest. Okay, so for example, you bought a bank bond. You bought a bond from the bank worth $100,000. Okay, the interest rate is going to be 6%, and you can redeem it in 5 years. So in this case, usually bank bonds, right? You actually have to wait till it's been aged before you can even take it out, right? If you take it out too early, I think they charge you tax on that. Now, there's a lot of rules when it depends on when you can take it out, but in this case, we're just testing it out, right? Because our main goal is to look at whether it's good to invest into a bond or good to invest in a credit card or a loan. So in this case, here we're looking at our principal, right? Our original investment was $100,000. Our rate is 6%, right? Every time we see a percentage, we need to automatically convert it to a decimal point. So we're looking at 0.06. And then time, it's already given in years, so it's 5 years. Okay? So this is how we're going to go ahead and start with our first formula, which is going to be to find out how much interest is. In this case, it's going to be PRT. So P times R times T. So we're going to take our $100,000, we're going to multiply by 0.6, and then we're going to multiply that by 5. And then what do we get? We get 30,000. Sorry. Sorry, guys. I was about to choke there. We get interest of $30,000. Okay, so that's a lot. But again, because we're looking at simple interest, we only get charged interest once. So here, boom, $30,000 is your grand total of interest that you will be collecting in 5 years. And then lastly, how do I find how much my future value is? You're going to add your original investment. So 30,000 plus 100,000, you're going to get 130,000 at the end of 5 years. Now, that's actually a really good bank bond. But in reality, who has $100,000 to invest? So, there you go. This is a typical bond for you, right? Usually bonds, they can be anywhere from 5 to 10%, but then again, it depends on also how much you invest, right? Obviously, if you invest in $10,000, the maximum you might be able to get is anywhere from 2 to 3%. Now, that's a lot, and depending on the time, right? And that's where it gets you. Okay, so for those who are looking into investing in bank bonds, the only danger is if you take it out early before it's been aged, you can be subject to tax. But if you never know, we might not live that long, right? So there's a lot of bank bonds out there that are 10 years old or even, 20 years old. You never know. You never know when you'll be able to live that long, or maybe you might give it to somebody. But the number one thing is when you're dealing with a bond, you have to make sure that it ages all the way. Like it accumulates the time that it's meant to be for. Okay, so in this case, my example here, I have $130,000 at the end of 5 years. Okay, and that's simple interest for you. So you guys, everyone can do this because everyone has a calculator. Now let's go ahead and, any questions in regards of simple interest? It's pretty straightforward as far as calculating and also just determining the value. Pretty straightforward. All right, so let's go ahead and look at compound interest. Now, just by looking at these equations, you can already say, yes, this is a very complex kind of calculations. You do need a special calculator for this, but I'm not going to ask you guys to go purchase an expensive calculator because the graphic calculators nowadays are anywhere from $100 and above. I'm not going to ask you to do that because for the sake of this class, you don't need to invest in that. Because we have Excel. Yay! Excel can do these formulas for you. And it's free. So here we're looking at the equation. So again, I told you that when we're looking at compound interest, we're introducing to another variable, and that's n, which is to calculate the number of times of interest that you're going to be hit with, right? You're going to be calculated with. So in this case, interest, right, is going to be your future value minus your principal. Okay, so already we know from there, great, we need to solve for future value first in order to solve for the interest. So in this case, future value, right, is going to be your principal times 1 plus your rate over the number of times compounded. And in this case, we call this exponent, right? Up to the number of times compounded multiplied by time, all right? Already that was a mouthful. So here, if we look at the actual equation, right? It's a lot more complicated than you would think. So I've also included the Excel on how to type this in Excel if you have it, right? So in this case, we're looking at P parentheses 1 plus R over N, and close parentheses up NT to the NT power, okay? So if I really had to break this down for you, every time you're getting the principal, you're multiplying it by 1 plus the R over N, which is your rate divided by N. So you're getting your rate, and depending on how many times you're getting charged the interest, right? It's going to be 1 plus that, and then on top of that, it's also going to reoccur again for every many times that you have the loan for. So it's going to multiply it again by the number of times that you have the loan for. So in this case, I'm going to go ahead and dive into the example so it's a little more clear on what I'm asking you and how this formula is placed in here. So again, we have another example, right? We have bought a bond from the bank that's worth $100,000, right? The interest is 6% and it is compounded quarterly, meaning every 3 months it's going to be compounded. So if it's every 3 months, what's that in a total amount of years? How many times is that in 1 year? 4. Good. And can be redeemed in 5 years. Yes, I know this is simple interest. Simple questions, but gotta make sure you guys know what quarterly means. All right, so here we have $100,000 as our principal. Here our rate is 0.06. Here our number of times compounded is 4. And lastly, our time is in 5 years. Okay, so now that we have our variables and we have our numbers all filled in, now we can go ahead and plug it right into our formula. So again, in order to solve for interest, we need to solve for future value first. So we need to plug in our numbers into each letter over there in that little formula. And, I'm not going to ask you guys pull up your Excel because we will do that in the example, okay? But by plugging this in, all right, so here, this is exactly what you're going to plug in into Excel, all right? So this is just a little, what do you call it? A little shortcut, a little, a little study tactic for you guys so then you can use Excel to your advantage. So this one, I gave it to you guys so nicely, right? So the one thing that you have to be very careful is making sure that every single parentheses that you open, you have the equal amount closing on the other side, or else Excel's gonna not recognize it and they might throw your entire formula off. So it's important that you do P with the asterisk, right? P times parentheses 1 plus parentheses R divided by N parentheses caret parentheses N times T close parentheses. So if you guys are not familiar what this exponent or the caret is, it is your shift 6. So make sure that you look on your keyboard and recognize that it's your shift 6, okay? And that's how you activate that exponent, okay? So by plugging in these values right here, right? I don't expect you guys to be able to do this because you need a special calculator for this. You should get a total of $134,685.50. Okay? And in this case, we solve for our interest, and the interest that you've collected within those 5 years is $34,685.50. Notice that this was the same exact bond, except if you compound it, right, you're actually collecting more interest, right? And that's where the credit cards get you, right? Instead of slapping you with one interest rate one time, this is where the credit card, right? If you owe $100,000 and their interest rate is 6%, which is very low, by the way, you are going to be slapped with, $34,000. All right, that's a lot. You increased it by $4,685 versus your previous one. You only had a flat $30,000. So this is again an example where you see this, and this is the most common one that you will see, because oftentimes you are always compounded annually, and this is also for us to kind of think about it. If we are investing in a credit card, or if we are investing in a bank bond, we can see which bank bond, or I'm sorry, not bank bond, a loan, right? We can see which loan gives us the best bang for our buck, kind of thing, right? The lowest interest, right, doesn't always mean the best thing, because if you have a shorter amount of time to pay it off, then you're more likely to have to pay a high interest. And then vice versa, the longer that you owe, the lower the interest. So either way, no matter where you're given out in any situation, you can compare and contrast which bank loan is better for you. Because ultimately, at the end of the day, do you rather pay into the interest, or would you rather, try to pay off as soon as possible to get the debt off? So you want to pay more interest, or you want to pay less interest? And that's all about what this whole chapter is about. Okay? So, other than that, any questions in regards to compound or simple interest?
It looks like the compound interest is just like an interest over an interest.
Yes. So instead of calculating interest at the end of the year, we're calculating interest multiple times per year. So, yes, and we'll go ahead and look at some example here. So I have prepared you guys. I have this document for you guys. If you guys have Excel, you may please go ahead and open it up. But if you don't, that is completely fine. I will take that into consideration. But I believe all of you guys have Excel on your computers. Is that correct? Okay, I know for sure. Yeah, I know you have it. I know Nora has it.
I have it.
Okay, Julie has it. Oh yeah, because you took the Excel class. Yes. Adina, do you actually have yours after you've taken your Excel class?
I had Excel before I took the class.
Perfect. And you have the actual program?
I have Excel on my computer, yes.
Perfect. All right. So again, if you do have Excel, that's a good thing because you'll be able to do this calculation with me. But if you do not, unfortunately, we'll just have to just you're just gonna have to be able to try to do it on your own separately. You can go ahead and go on the internet to see if there is some kind of free scientific calculator. I'm so funny. See if there's some kind of free scientific calculator out there that can do exponents. All right, I know that there's a lot of free junk out there that you can find. So go ahead and take a look on that. So you'd be able to answer some of these questions. All right. So here we will go ahead and look at this exercise 10.2. There should be a total of 5 questions. Okay. And let's go ahead and dive right in. So I'm going to make it a little bigger just so that we could be able to see it. Okay, so our first example here is going to be asking us about simple interest. So again, I took the liberty to also include the formulas for you guys. You don't have to look for it. But let's go ahead and look at our scenario here. Okay, so if you bought a bank bond worth $225,500, right? And the simple interest rate is going to be 7.45% and can be redeemable after 3 years. So how much interest will you be collecting? Okay. Now, of course, I've entered in. I've had this is how the table looks like. You're going to be given a few things, right? You're going to give your principal, your interest rate, and your time. And the thing is, you're going to either solve for either the interest or the future value. All right. So how much interest will you be collecting at the end of 3 years? Okay. So here, I notice that my principal is going to be $225,500. My interest rate is going to be 7.45%. And we have our time is going to be 3 years. So in this case, all my variables are all of my variables are there. So let's go ahead and calculate how much interest I would actually be collecting. Okay, now if you're using Excel, you can go ahead and either type in your number. So here I'm typing in 22550. I'm going to multiply by the 7 by 0.075, and I'm going to multiply that by 3. And I should get $50,399.25. Is that what you got, Lynette?
Yeah.
Okay.
The interest for that.
So that is my total interest as of when I claim it in 3 years. And to solve for my future value, it's going to be this number plus this number. And it should be $275,895 with 25 cents. Okay, pretty straightforward in regards to simple interest.
So the time that you indicated there is years or months?
It's 3 years. So okay, and then we'll look into an example of when. Okay, and we'll look at an example of what happens when we're given like 3 months or 90 days. Okay, so that is how you do the very first question. So question number 2. So here we're given the same scenario, except we're actually going to be solving for all 3. Oh, come on. Okay, that's good, right? I don't want to mess with anymore. So here we're given 3 scenarios, right? We're given 3 different principles with 3 different rates and 3 different times. Now we'll go through each one. So in this case, because I have like letters in my actual boxes, I can't actually cell reference, so I actually have to type it out. So let's go ahead and solve for the interest for the first one. So what is my principal? It is 15,000. All right. And then what is my interest rate? 0.0512. And lastly, what is my time? 5 years. 3,840. And I'm gonna format these so they're in dollar style. Okay. Okay. So then, how do I solve for my my future value here? Interest plus principal. Good. Now, let's look at our next question. Our next one. We have a principal of $4,521.50. Our interest rate is going to be 2.45%. And lastly, here is our scenario. We have 90 days. Now again, when we look at this kind of equation, we need to figure out, right, how much 90 days is converted in years. All right? So in this case, how much is 90 days? 3 months. And how much is 3 months in 1 year? 4. Good. So that means how are we going to convert this is 90 days should be equivalent to 1/4 of a year. And that's exactly how we're going to convert this. So this right here, 90 days, 3 months, right? 30 days equal 1 month. So I'm going to go ahead and write it down here. 30 days equal 1 month. Okay? So now that we know that it is 90 days, we know that's going to be 3 months, right? And we know that 3 months, okay, is equal to 1/4 of a year. So in this case, when we multiply it, we only want to know 90 days worth. So in here, I'm going to put is equal to 1/4. So when you multiply this, you're going to multiply it as if it's going to be 1/4 of a year. Okay, is everyone following along? Does everyone understand this part? We need to convert this time into years.
I don't understand it, but I'm following along.
Okay, so because my time is very short, it's limited, right? Because the one factor and why I have to do this is because right here, my rate is an annual rate. it is an annual rate, meaning that this is what I'm going to be multiplying my principal per year, right? Not per month, not for per 90 days, it's per year. So, I mean, you could do this, you could divide it by the 3 months, so then you'd get how much it is for each month. But in this case, I'd rather you just do, just convert everything into years. So in this case, 90 days equals 3 months, and 3 months out of 12 months, right, equals 1/4. So I guess maybe that's a better way of looking at it, right? How many months are there in a year? There are exactly 12 months, right? That's how many months there are in a year. But when we're looking at we're only going to calculate 3 out, so 3, okay? So 3 out of 12, which should give you 1/4. Okay? So in this case, we're going to multiply across again, but this time we're going to multiply $4,521.50. We're going to multiply by 0.245, and instead of multiplying 90 days, right, it's converted into years, and we know that 90 days is equivalent to 1/4 of a year. So I'm going to go ahead and multiply this by 0.25, because I know what 1/4 of a year is. It is pretty straightforward, right? We calculated earlier. And what do we get here? $27.69. Wow. So in 3 months, I've only accumulated $27 of interest. So that's going to give me a grand total of
$45.49.19.
perfect. Good. Okay. So let's go ahead and do again the second example here. All right. So everything is good except for time. What is my time converted to in years? I'm sorry, what was that?
0.5.
0.5 or 1/2. Yes. Okay. 0.5 or 1/2, because 6 months, right, is half a year. All right. So now we understand that, okay, we need to convert it because we have an annual rate. So in this case, what is my interest rate? Interest here.
$537.40.
Wait, what was that?
Oh, 15,153.74. Sorry.
Okay, and then you added it, right?
Yeah.
There you go. Did I add that or did I subtract that? That looks like I multiplied it. No, I added it. 9.5? Oh, okay. Well, 2 plus 4 is 6, so it is definitely 96. So, yes. So, see, now we're done, right? We can see what it is when it comes to simple interest right here. All right? Any questions in regards to simple interest? Pretty straightforward. All right? So question number 3 is now going to ask you to do a little complex, and we're actually going to be looking into compound interest. So again, I placed the formulas up here for you guys. Okay? But in this case, here our scenario is you got approved for a bank loan for for $5,500, okay? Interest rate is going to be 6.25%, which is a pretty high rate. And is compounded monthly, okay? How much interest will be collected if you decide to pay it off in 5 years? So here, our principal is 5,500. Our interest rate is going to be 6.25%, which is converted to 0.0625. The number of times compounded, right? It says here it's compounded monthly. So if it's every month, how many times is that in 1 year? 12 times. So this is a very straightforward real life bank loan example. Okay, and what is the time here? The time is going to be for 5 years. Okay, so this is where you're going to need to use your Excel for this. All right, so future value. The formula for future value is right at the top. Let me see if I could just lunge up just real quick. Oh, there you go. Perfect. So here our formula is right here. It's going to be the principal times parentheses 1 plus parentheses r divided by n parentheses up parentheses n times t parentheses. So by looking at this formula right here, we're going to actually have to press in and enter in all those information. Okay. Now, if you have your cells or your tables lined up like mine, you can just go ahead and, press or cell reference each one. So I'll go ahead and do that for the second. I'll go ahead and show you how to do the cell reference, right? So in this case, equal, right? We're going to grab our P, which is our 5,500. We're going to go times, open parentheses, 1 plus, open parentheses. We're going to grab our R, which is our rate. We're going to divide. Hold on, let me find my division. We're going to divide by 12. So we're going to grab the 12. Oh. We're going to close the parentheses twice. So if you notice, it's red right now, right? You need one more to close off that black one. Okay? And then you're going to do shift 6. Okay? And then you're going to open another parentheses because ultimately you're not just only going to, it's another formula that you need to enter. So my n, which is 12, so I'm going to grab my 12, and I'm going to multiply that by my time, which in this case it's being blocked. So I'm just going to go ahead and press my arrow key, and now I'm grabbing my time, and then I have to close it or else it will not complete the actual formula if you do not have that last ending parentheses. So good. Everything in my formula looks good. And enter to complete the transaction. So here I get $7,511.51 in grand total. That's my future value. Okay? And from here, how do I solve for my interest? It's future value first because it's always going to be bigger, minus your principal. Yes, but you got the variables correct. Okay, and we get a grand total of $2,011.51 worth of interest, and that's a lot. That's a lot. That's almost half the bond right there within the first 5 years. So instead of paying $5,000, you're paying $7,000. And again, that's a lot of interest that you owe and you're paying towards the bank. All right. Any questions in regards to how to do the formula? It's a little complicated, and you need to make sure that every key that you place in there is actually correct. All right. So let's go ahead and continue doing the next one. So again, I have another table, right? It's got variety to it. But yeah. Anyways, but notice that it's the same concept, right? I have 90 days and I have 60 months. 60 months. So from here, I know that 90 days is going to equal 1/4 or 0.25, however you want to convert it to. And we know that 6 months is equal to 1/2, or it's also known as 0.5. Okay, whichever one that you want to choose, I would recommend to just keep it as a fraction. Reason being is when you ever come across, let's say I have 5 months out of 12, you want to make sure that you get every single decimal point after 2. Okay, so in this case, my future value is going to be, for the first example, let me go ahead and expand these. So equal, what's my P? 15,000. All right, and these ones I've already converted I've converted the rate for you already. All right, times. What's the formula? So what number's next? I gotta do the rate. Mm-hmm. Divided by 4.
By the number.
Oh, four. I'm sorry.
Mm-hmm. 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 Carrot. Carrot. Yes. All right. So I get $19,344.83. So here, what is my total interest I will be collecting after 5 years? For the first example, mm-hmm. 4344.84. Yes.
Hey, Len,
Mm-hmm.
I'm a little confused by the formula because no matter what number you have in time, the future value doesn't change.
What do you mean by that? Because you're supposed to convert it.
What do you mean? You're supposed to convert it. What do you mean by that?
Wait. Ask your question again. Sorry.
So when you put the formula in,
Mm-hmm.
and say you didn't have years there, so you could have just selected that cell, so it would have been 5.
Oh, is that right? Because usually for me, I always get an error message because I have words in my cell.
Right. So if you take the words out, right, and you just cell reference.
Oh yeah.
It doesn't change the future value. That number does not change no matter what number you have in the time field.
Oh, interesting.
Like if you go back to your formula right now,
Mm-hmm.
just put future value and change your 5 to 6, it's going to be the same number.
What do you mean if I change my to 6?
Yeah. What the heck?
I know. I was gonna say, that is a number.
I do, but I was I was playing with it and messing with it, and it would not change. It was keeping it exactly the same.
That is strange, but okay. That is strange. I can tell you that.
So I I thought I had it in wrong, so I did it again, and it did it again. That's so weird.
Yeah, it should change because, again, ultimately the time. Right here, I'll go ahead and I'll test it again. So I put 4 in, right? Yeah, it changed my number.
I have something wrong then.
Okay. Well, I hope you know, time is very sensible when it comes to this exact thing. That's why if we were to do 90, right, our assumption is we're doing 90 years versus 90 days. So we can take a look into that and I'll show you. Again, we just looked at a time where we did 6 years, 4 years. It changes it drastically. Okay, we went from when you did 6 years, it went up to 20,000. When we went to 4 years, it went to 18,000. So the years definitely does change and give an output to it. Because again, that's what this whole thing is about, right? It's all thinking about time, value of money. This is what's going to happen in the future, right? All right. Okay. Ooh, hold on. I'm gonna let Vina in right now. So give me 1 second. Where'd she go? Where'd she go? Okay. All right. So here we're yes.
Real quick,
Mm-hmm.
I'm trying to download the Excel on this of this exercise to my computer, and
Mm-hmm.
it's not. You don't have it in the Excel form. It's in PDF. It's in everything else but the Excel. You do have an exercise, but what's uploaded is not the one that you're doing right now.
It should be. It should be because here I'll show you the example because so did you take that extra step to open it up in a new window?
Mm-hmm.
It should be. Let me see. Let me see. Where are we? Chapter 10.
The Excel.
You just passed it, Lynn.
Okay, hold up. I'm looking for green. There you go. So when you click this, right, if you download it from here on this page, it's a PDF.
That's not what you're working on right now.
It's not working?
No, so that's not the question. That's not the problem that you're working on right now.
It is not.
She's just on the 4th tab.
I'm on the 4th tab. Yeah, so this workbook has all the questions in here.
I don't know why when I downloaded it, it didn't show up. Let's see. Nope, it's not. I don't have it in mine when I downloaded it. Anyway. Oh well, I'll just pay attention and figure it out later. I don't have time right now.
Okay.
I just want to go ahead and pay attention.
Okay. If anything, I could probably work with you after class to try to do it, or if anything, if you can absolutely not download it again, I can email it to you.
Okay, cool.
Okay. So now we're back here. Okay, so let's go ahead and solve for the rest of the problems. And then we'll do question number 5. And then we'll take a break because it's already 9:30. So let's go ahead and go. So in this case, we're looking at the same exact formula, but this time we're looking at time to be 1/4 of the time. So we've converted that into decimals. We already know it's 0.25. It's an even number. So let's go ahead and plug in the numbers. So what's my P? I'm going to multiply. All right. Not close parentheses, open, another open parentheses. Mm-hmm. 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 Mm-hmm.
times 0.25.
And close our. Mm-hmm. And what's my formula here? I mean, what's my future value here? Oh, okay, okay, okay. Well,
I would do
45,
this.
49, 11.
45, 49, 11, and our interest here is going to be
2761.
27, 60, 61. Okay, so, all right, and then what's the next one? I'm gonna just drag the formula. Actually, no, I can't drag the formula because I typed in this one. So equals P times 1 plus open parentheses R divided by N, close, close, close. Okay. And what's my future value here?
399, 378, 16.
399, 78, 16. And my interest I'll be collecting is
15, 252, 94.
I did the wrong one. I think I multiplied it by accident. Yeah, $15,000. Okay. $15,000. So if you were to get a bank loan for 7%, oh my gosh, or you bought a house, whatever, right? That's $300,000 for a house. Your bank charges you 7%, which is pretty high for a house, and you have to pay. They charge you every 3 months. They charge you every 4 months, so 3 times a year, and they do it for 6 months. Yeah, that's a lot of money. Okay, so let's go ahead and look at this. So again, we're gonna compare. These are the exact same problems that we saw here on question number 2, except ours doesn't have the number compounded, right? So in this case, here we notice that our interest here is, okay, it's a lot smaller or it can be a lot bigger. Now in this case, depending on how much you owe, or whatever that you're looking into, whether you're doing a loan, right? So here the first one is about roughly 3,840. And the next one's 2769. And the last one's 15,115. All right, then let's go ahead and compare that. In this case, I have definitely a lot more interest on the first one. Second one, I'm actually a little less. Okay, so this is because I only have 90 days to collect it, and it's doing it twice. So here I'm actually resulting in a lower interest. But if we look at the third one, we just racked up another $100 worth of interest. Okay, so comparing 15,250 compared to 15,150. Okay, so like I said, most common occurrence is you're going to be more likely to see a compounded interest versus a simple interest, just because that's just how it is. All right. So what I'm going to do today is I'm going to show you a very typical scenario. All right. Here all right, this is where I'm going to show you, well, what happens if how we have statements, right? Or if we do a loan and we pay it off, right? And as we pay, what you have to do is you have to recalculate the principal, recalculate the interest, etc., etc. So in case you want to know what you're dealing with when you're looking into how much principal you're actually paying versus how much interest you're actually paying, this is how you'd be able to determine it. So in this example here, journalize the bank loan from example number 3. So we have to do number 3. Okay, this bank loan was made on June 1st, 2020. All right. Monthly payments are variable. We already know that. And due every first of the month. Okay. There are no hidden fees and 0% APR. Okay. Bank loan is effective immediately. All right. So journalize this trend the first 3 months of payments. Okay. So here we recognize that we got the bank, right? We're obviously not going to pay them, but what is our original principal? So we're going to go back to question number 3, and we got the bank loan for 5,500, right? And our interest rate is 6.25%. And we're going to be doing it every month. We're going to get hit with the interest every month, and we have a total of 5 years to pay it off. Okay, so I'm going to go ahead and plug that information into my scenario here. So my principal is going to be 5,500, right? So I've already calculated the future value, right? We've already solved that by doing P, which is my 5,500, and we multiplied that by 1 plus the rate was 0.06, 0.0625 divided by 12, because we're getting charged monthly. And we're given the scenario that we have 5 years to pay this off. So here, my future value is going to be so this is my future value, right? And my interest that I've collected on this is going to be this minus this. But one thing that you need to know is you also need to divide this by 12 because you're getting a monthly interest, right? Oh, what happened here? So this minus this, right, is 2,000, but we're figuring it out how much interest I'm collecting every month. So in this case, right here, it already tells me I'm going to be charged that much interest every month, and that's a very high interest. Okay, so this is also known as your minimum payment, as they always say, right? So that's how much interest I'm going to be paying every single month. So if I do not pay this, this is a very high interest. 6.25 is a very high interest. So I'm owing $100 every single month for the next 5 years. So by looking at this, right, I'm going to say I'm going to make a payment, right, on my June 1st. Now, let's go ahead and take a second before we actually solve for the rest of the table and actually journalize this transaction. So again, we bought our loan on June 1st. Okay? So what am I receiving and what am I incurring? Okay, so in this case, how am I going to journalize this? So I got a bank loan. Hello? Are you guys there? Okay, so I'm receiving a bank loan, right? What am I getting out of this bank loan?
Is it cash?
You can receive cash. Good. So in this case, I'll go ahead and write that I received the cash.
And then would it be a notes payable or something like that?
Why would it be a notes payable?
Is it the liability?
It is a liability, but in this case, it's my assumption is, since I'm using the information from question number 3, right? This loan is for 5 years. So can it be a notes payable? Can you negotiate with the bank to expand the time for you to pay this?
Yes.
It depends. Now, if you have really good interest, you might be able to. But in this case, this loan, I don't, this could be a business loan. This isn't a mortgage loan where you can refinance.
You can refinance.
In this case, not if it's a business loan, you definitely cannot refinance a business loan. Same thing. Okay, wait, and then it's a long-term liability, so I'm going to go ahead and just making the assumption that I just received a bank loan, a simple bank loan. Okay? All right? You could either make it a bank loan payable because now it's a liability, or you could just do it just loans because that already, the assumption is you already owe that amount. Now, how much did I actually get this loan for?
5,500.
5,500. Correct. Where's my interest go? Where does my interest go? Oh, Mia, I think you're cutting in and out. What was that?
Is that a payable, your interest?
It is definitely a payable, 100%.
Is it an expense?
It's also an expense when you pay off the interest. Okay. What my question to you is, do I journalize the interest now or do I journalize the interest later?
Later.
Because on July 1st, so you calculate payment and then whatever the difference.
Good. When you get your loan, your interest starts that day. As in, when you get your loan, that's when it starts calculating interest. So you don't charge yourself interest because you haven't accumulated any time when you're owing this money. So in this case, when you journalize it for the first time, your loan, you do not need to include interest because it always is the month after. Same thing with a credit card, right? When you apply for a credit card, you charge the first month. They give you that free month, and then they whip you with the bill on the second month. Okay? So in this case, interest is earned. You have to incur it. Like it has to get started first. But in this case, we don't have any interest because we don't have time. We just got the bond, or we just got the loan. So we leave this alone. Now, we decided that we're going to pay our first $200. Okay? Now, when we pay to the whole entire amount, right? We don't pay towards the principal because that's just the reality, right? We don't actually pay towards the principal. Okay? And you're going to learn this unless you actually talk to the bank, right? And say, I want this money to go towards the principal. But there are some, there are some negotiations that you do need to have prior, right? You need to pay the interest first before you can actually start paying towards the actual principal itself. So you want to be very careful. So if you're making two payments every month, then once you cover your interest for that month, you can talk to the bank and say, I want to pay for my principal, towards my principal. So the next paycheck you do, or whatever payment that you do, it's going to go actually toward the amount that you actually owe the bank versus paying towards the interest. Now, in this case, we are paying $200, and we know that at the end of the day, we need to be paying towards this future value amount. So here, I can't pay towards my print. Oh, hit the wrong one. I can't pay towards my interest. I cannot pay towards my, I can't pay towards my principal. But in this case, let's just go ahead and do it, because right now my future payment, right, should be, if this is my monthly payment, that means I currently owe this plus my monthly interest. So I should be right now currently at $5,667.63. So that's my current statement that's billed to me right now. So this is on July 1st, right? I opened up my statement. This is what it's going to show in my statement, saying you originally borrowed $5,500. Here's the monthly interest. Boom. This is your this is what you currently owe now. So this is my new principal. So in this case, my new principal is going to be this 5,600, right? But what I'm going to do is I'm going to take that principal and I'm going to subtract my payment, because that's the purpose of this payment, right? I barely covered my interest. So in this case, that's my new principal now. This is my new current balance as of what I owe now, because I paid the interest and I also paid a little bit to the portion. Now, knowing and understanding this, my $200 paid for this $167, and whatever remaining from that actually went towards my principal. So in this case, when I journalize my July 1st, right? What am I actually paying? What am I paying towards? You're paying towards your interest, yes. So interest expense. In this case, it's interest expense because you don't owe it yet. Interest expense. And then what else are you also paying?
Loan rental,
Say that again, Tennyson?
the rental,
What's the renter?
rental in the sense the monthly, because the loan is payable in months, right?
Yes. In this case, yes. I think that's kind of what you're trying to say, Tennyson, that you're actually going to pay the monthly payment for, so bank loan. So you're actually going to pay a portion of the money to your bank loan. And of course, you're more likely to pay the bank using your checking account, right? You either transfer the money or write a check. Usually that's typically what happens. They don't accept credit cards to pay off loans. So here, we've already calculated the interest, right? The interest was $167.63. So here, hold on, $167.63, and we paid a total of $200. So out of that $200, how much money actually paid towards the principal? You only paid $32.37 to your actual principal. So this is exactly why credit cards, this is where they get you. You owe a lot on your credit card. You're going to be paying 100% towards your actual interest and actually starting to pay off your actual debt. So again, you may, for bank loans, that's the only exception, right? That they're the only kind of people that can be able to have control of that. If you're working with a credit card company, right? Let's say Chase is your credit card company. You can for sure, that will never happen. So every payment that you do pay, it will just go towards mainly the interest. So here we've only paid $32 towards our actual principal. Let me see if we're good on time. Okay. All right, so now that we have a brand new principal, right? This is my interest plus the payment that or subtracted the payment. I guess I could say it that way. So in this case, I have to recalculate my new formula because now my principal has changed, right? And that's exactly what most credit card companies or banks do, right? They take the most current balance, right? Including the interest, right? And they just keep recharging the interest on top of it. So, in a sense, Lynette's right. You're getting charged interest on top of interest on top of interest every single month. And that's why that's why we have the exponent available. If you guys remember back in math, every time you have an exponent amount, you're multiplying it multiplying it by itself. I don't know if that makes any sense. So for example, right, I have, right, let's say for example, my exponent, right, is going to be 2 up 2 up 2, right? That is basically 2 times 2. It's going to be timesing whatever's in the bubble by itself. So in this case, yes, you are multiplying the interest on top of its interest. So, I don't know. Again, that's a lot of complicated stuff, but this is what typically truly does happen, right? So we have a new current balance, right? It is a slightly lower than it was before, but let's go ahead and solve for the future value of this. So again, I know it's 1. Come on, parentheses. So it's going to be R, which is 0.06625. So again, your interest rate will never change unless you get it renegotiated, right? But in this case, that's less likely to happen. N was 12, and we have 5 years to pay the whole thing off. Okay, boom. So here is my new future value. And with that, of course, every time you make a payment, right, and you make a little more than the minimum, right, you're actually going to be decreasing your interest that you pay, right? But in this case, even if I divide it by 12, I've only decreased it by $1. So now my new principal from here is going to be now 5,634. Okay? So I'm going to go ahead and make that indication here. So in this case, I paid my July bank, right? And now that July is over, it's August now. I'm going to be hit with interest for $166.64. So in this case, let's say I do make a payment this time, I'm going to pay a little more. I'm going to pay $250 this time. So here, I'm going to grab this amount, right, my new balance, subtract this principal here, and I'm going to now lower my new principal to be a lower amount. Now again, let's go ahead and journalize this time what happened on August 1st. So again, you're going to have the same exact scenario, same exact journals here, right? We're going to have an interest expense, right? Because we're paying off our interest. And here we're paying off a portion of our loan, okay? But actually, how much interest am I actually paying? $166.64. Yeah. So, oh, I guess I accidentally, no, well, keep going. So here, I'm paying $166.64, and I made a payment of $250, but let's see how much money I actually paid towards the actual principal. I only paid $83 for my principal. Okay, so seeing this number here, right, in the future, as I keep making my payments, at the end of the payments, I'm going to end up with $2,000 worth of interest I'm paying. And that's a lot. Okay, that is a lot. So I'm going to go ahead and finish out the rest of this problem. So again, I'm going to recalculate my interest here. I don't know if I could. 0.0625 divided by 12, parentheses, up, caret, open, 12 times 5. I wonder if I could, or if it would. Okay, so here, my interest now that I'm going to be actually collecting now should be $19.69. All right, which should give me right, a grand total of this much per month. So now I'm shrinking down my interest slowly, right? My minimum payment is slowly changing. And then from there, I have to add this number because this is how much I owe now. Now this time I'm going to be a little more forceful, and I'm going to say I'm going to pay $300. So I'm going to take this number and I'm going to subtract this number. Okay, yeah, it did not take my formula. Okay, so I want to take this number and subtract 300. I don't know what number that was. And now I owe 5,248. And again, if I were to go ahead and journalize this, my end result is going to be the same, right? I'm only paying maybe a little more to my actual principal. So what was this? This is September 1st, right? My total amount of interest I am actually paying off is $164.10. I'm sorry, I said that wrong. Okay, so 300 minus my interest I paid. Therefore, I'm only paying actually $135.90 towards my actual principal. So by me making all these extra payments, right, the bigger I pay off, the bigger I'm actually tapping into my actual principal, which it's common sense. But in this case, this is a typical example of if you were to calculate and how much you should pay, right? If you can determine, right, because they're going to give you a minimum payment, right? The minimum payment only actually just covers the interest. Okay, so they could give you the minimum payment of $165, whatever, right? So if you by doing this, right, and knowing that if you pay more, obviously you're going to pay the interest, but you're also paying towards your principal. Again, when it comes to banks, you definitely want to renegotiate if you're making multiple payments for this loan. And of course, it's better to pay quicker because less interest will be charged, of course, right? And if you can do this 5-year loan and pay it off within 3 years, right? There you save yourself 2 years of interest that you will be punished for. But however, just remember, no matter where you are in time, every time you enter in your new principal, at the end of the day, you're actually going to be paying off this $7,000. So they're going to already include the interest for you for that whole entire 5 years worth of span. So no matter, even if you pay it off within 3 years, you're not paying that $5,000 off. You're paying the total amount. And that's what tricks you and that's what gets you. Okay? So other than that, any questions in regards to this real life example of how to even calculate this interest, this compound interest, and what is the results when you actually just pay the interest off? Right? Any questions? No? Okay. All right. Okay, so for this